Good morning, grade 8. Welcome back. Today, inshallah, we're going to continue lesson 2 of chapter 20. We talk about magnetism and electricity. And as we said last time, that magnetism and electricity considered to be two faces of the same coin or two sides of the same coin. And we said that magnetism somehow is related to electricity. In the last session, we explained that once electric current pass through or flow in a wire, it creates an electric field. This electric field has a magnetic field also, or create a magnetic field around it. That's why the current, once it passes through a wire, it could make the needle of a compass to deflect. And said scientists find this idea, or once they find that the electric current has a magnetic field, they start to think if they are able to use the magnetic field of a current to create a magnet, that's what pushed them to make the electromagnet. So as we explained last time, also what is the electromagnet? We said that we get a magnetic material, okay, or a ferromagnetic material that mean iron core, like this cylinder in the middle. Then we start to coil a wire around it, okay. So by coiling the wire around it and connect it to a battery, the current will flow in that wire because it's coiled. So the electric current will pass for a long time around the core. So focus the magnetic field. This magnetic field of the current will change the arrangement of the atoms inside the iron, okay, to be a magnet. So in that case, we call this an electromagnet, okay. So like this, we could use electric current to make a magnet. And we said that this electromagnet, we could increase its strength by using more powerful battery or electric source, or by increasing the number of loops of that coil of the wire. So that is the electromagnet. Then we start to explain the uses of the electromagnet, and we said that electromagnet could be used in different purposes. One of these purposes, for example, used in speakers, as was said. And also, we said that electromagnet could be used for carrying heavy iron blocks, okay, like old cars or something like this, okay. And the best thing about the electromagnet, rather than the permanent magnet, that you could control the strength, or even you can make the electromagnet stop at work by cutting the current, or by turning off the current. Also here we have a very important thing, okay, in which electromagnet can be used in, which is the electric motor. So electric motor is considered to be an application for the electromagnet. That means that one of the or the most important component in the motor is the electromagnet. So what is electric motor? Electric motor, that's a device that is going to change the electric energy into a kinetic energy, or cause a motion, like all devices that you have in your home that has a motor. For example, your washing machine, it's contain a motor, okay, make it move, okay. So that I keep moving like this. And also here, okay, the fan also. So toy cars, a lot of things, okay, that is already use electricity to make a kinetic energy, they contain motors. So how does these motors work, or what is made up of? Let's watch here together, guys. So as you can find here, okay, that is the structure of the electric motor. So what is the structure? First of all, we have two permanent mag or we have two poles of a permanent magnet. So this is the north pole and south pole. It's a permanent magnet, normal magnet. Between these two poles of the normal magnet, we have an electromagnet. As we said before, the electromagnet is just an iron core that is surrounded by a coil wire. Then we're gonna just attach this coil wire to battery. So once we attach the coil wire to the battery, that will make this to be an electromagnet. So what would happen in that case? Actually, we're gonna find that the north pole of the electromagnet will repel from the north pole of the permanent magnet. So it will move or turn in that direction, and it will be attracted by the south magnet, okay, so, or the south pole, so it will pass to the south pole. So finally, or as we imagine that, okay, so suppose that we're gonna find that after a while the pole of the electromagnet will be like this, okay. That's here, that's the coil around it, okay. So suppose the N will be in that side and the south here, because the south will be attracted to the north and the north will be attracted to the south. But unfortunately, like this, it just will make half a cycle and stop. So like this, it will not make a motion. How we could ensure that it keep rotating or moving to ensure that we still have a motion? So in that's here, we have this very important part, these two metal pieces, the green one and this yellow one, which we call the commutator. So what is a commutator actually? Actually, commutator is just two metal pieces that are connected to the battery, and they have an axis, okay, that's connected to the cylinder here, or the electromagnet. So what's the purpose of this commutator? The purpose of that commutator that as it moves like this, you're gonna find here that the wire will always, as it rotates, it will change the direction. What does that mean? That means, for example, here this orange wire is connected to this side now, which represents that negative pole of the battery, while the green one is connected to that, which represents the positive pole of the battery. Once it rotates, so you're gonna find, okay, here that this yellow part, okay, or this part, okay, yellow wire will touch the positive. So that means this one will turn to be the positive and the other one will turn to be negative. That means after it rotates and the north pole will be here, it will touch the opposite pole of the battery. That means it will be positive. So like that, the north will change to be south. And the green one, okay, it was already south. Once it touched this orange part, it will be the north, okay. So here, south beside south, that will repel, okay? So it will keep moving another cycle. Once it passes to the other side, it will return again. So commutator ensure changing the poles of the electromagnet, which keep them repelling with the poles of the permanent magnet. So like this, the electromagnet keep rotating and it not stop moving, okay? So again, one more time here, guys, to clarify the idea. We said that electric motor is just a permanent magnet. Between the two poles of this permanent magnet, we have an electromagnet. So once the current passes, okay, this electromagnet will have two poles, north and south. So the north pole will repel from the north pole, make it move in that direction, and the south will repel from the south, so it move here. But as we said, unfortunately, if just like that, okay, so once the north pole become horizontal position like this, north and south, so what would happen? It will stop because the north is already attracted to the south and the south is attracted to the north, so it will not move anymore. So here that the rule of the commutator. The commutator, okay, it will change the pole of the battery. That means after time, it will make this wire, okay, as imagine that is rotates. So this will touch that part, okay. So in that case, it will be this north pole will change to be the south pole, and the south pole will change to be a north pole. So like this, south beside south, they will repel, north beside north, so it will repel. So it will keep moving. So after a while, it will be vertical again. Once it become vertical again, okay, so the two poles, okay, of the battery return to the position, okay. So in that case, okay, that will be north and that will be south, so it will keep repelling, so it will keep rotating like this. So commutator ensure that or change the electric poles of the magnet, so to ensure that the current to ensure that sorry the magnet keep repelling. So as you can see here, guys, the commutator causes the current into the electromagnet to change direction, okay, which reverses the poles of the electromagnet. So like this, the magnet keep repelling from the permanent magnet and keep rotating. So here, that's the idea, or that's how the electromagnet, or that's how the motor works, okay. And like this, okay, we could find that the electromagnet has a lot of applications or uses in our life. So let's wrap up what we studied in this lesson quickly. We said that once a current passes in a wire, the current has a magnetic field around it, okay? And then we said that once we have this magnetic field, scientists are able to focus this magnetic field around a magnetic material or an iron core. So this iron core could change to an electromagnet. Then here we said that we could use this electromagnet in a lot of purposes, like in speakers, okay, carrying heavy iron blocks, and also it could be used in making electric motors, as we just explained here. Okay, so let's try to answer this following question together. What happens to the strength of magnetic field around current carrying wire when the wire is wounded into a coil? That means imagine that we have wire, but instead of making the wire straight, we just coil it. So in that case, the magnetic field would increase, of course, okay. So then here we have, which is a device that uses electric current to produce motion. So we're going to use electric energy to produce kinetic energy, so of course it's electric motor. And finally here we have this question: when an electric current is supplied to an electric motor, the unlike poles of the permanent magnet and the electromagnet to what? Okay, so it's here, so the like, so they are gonna, okay, attract each other. So here, that's our lesson, okay, or the last part of this lesson. Please study the lesson very well from your textbook, and if you have any question or something not clear, you can ask anytime. Thank you, guys, and goodbye.